Hi, this is a really quick video to show some screenshots, or video really, concerning the Roeder and Schwarz MXO4's new log frequency axis feature, which came in a firmware update about a week ago. For a more general look at the spectral analysis capabilities, please see the separate full review video, which demonstrates it at about 9 minutes 20 seconds into the video. At the time that review was created, for EMC pre-compliance testing, it was awkward to use the linear frequency axis, but now that will be greatly improved with this new update. What this new feature does is, obviously it converts a horizontal axis into a view where decades have equal spacing, which means that for this simple test with a span of 100 MHz, the 10 MHz signal of interest is not squashed up at the left side, and one can more clearly resolve low frequency content that is normally bunched too closely together, as well as the high frequency content that may be more spread out often. This quick test was just to see that the log mode behaved as expected. Incidentally, I just discovered that as well as colours, transparency levels can be set for traces. So for instance, the spectrum max hold colour is very slightly transparent if you look closely, to allow the normal spectrum trace to show through it. The log mode can be extremely handy for working with audio signals. The span here is 10 Hz to 100 kHz, and yet the 1 kHz signal will be in the centre of the display. The display actually almost looks as if it is frozen, but it's actually updating. The signal is just very clean and sharp. The resolution bandwidth is 10 Hz for this example. This wouldn't be possible for such a low frequency signal with normal spectrum analyzers, so the MXO4 capability really fills a gap here. That's quite a powerful signal, but here's a more realistic audio example with a 500 Hz tone shown in green. It is going into a DSP chip and the output is in yellow. The output tone can be seen on the spectrum display too. The DSP chip has a tunable notch filter which is currently set to 480 Hz, i.e. it's not doing much to the signal currently. But as soon as the notch filter is set to the same 500 Hz frequency as the incoming green tone, then the yellow output vanishes. This just goes to show how effective it is to use a spectrum view on oscilloscopes, because the yellow signal was so small and noisy that the detail was almost buried, but it will clearly appear on the spectrum view. Some signals are easier to recognise from a log frequency view, such as this pink noise. The noise drops off at 10 dB per decade, so it should be a straight line with this angle as shown here. This signal was created using the built-in waveform generator on the MXO4. I wanted to experiment with a bandpass filter for the 300 to 3 kHz speech band. This test could be done with the MXO4's built-in frequency response analyzer, or alternatively a white noise source could have been used, or a swept tone instead. However, for now I used a logarithmic chirp, and it is shown in the green channel. It is sweeping between 20 Hz to 20 kHz over a period of 6 seconds repeatedly. This is a crude way of measurement, it's not precise, but on the other hand, the yellow output also shows a lot that might be missing with other analysis methods. I can clearly see the ripple in the passbands, even in the time domain view, but you can also see the ugly response at the high frequencies at 3 kHz, where the amplitude increases. From the spectrum view, the resulting distortion is visible because the output from the filter is clipping at that point. Despite it being a very sharp filter, it's not a very good one as a result, and this test reveals that quickly, allowing me to modify it. And that's it. It's a short video, but I hope it was useful. Thanks for watching.